Hello. So today we're going to talk about Chapter 8, Section 2. The title is the surface area, or the area of the surface. We have about 4 cases here. So the first case is that we are given a curve y equals f of x, and we're only going to look at the length that is bounded on this interval a to b. So we're looking at only this arc here. So what you're going to do is revolve this arc around the x-axis 360 degrees. So this arc will sweep a surface. Okay, so it's going to sweep a space and they create this surface. So we're not talking about the empty space inside here. We're not talking about the volume. We're talking about the surface of this object. And this object is generated by the rotation of this curve about the x-axis. Okay. So the point is, the question is, what is then the area of this surface? So if you think of this as an object, so the area of the surface of this object. So we take a simple case, right? Simple case is that if our curve is just this horizontal line y equals c, and our axis of rotation is still the x-axis, and the interval is on the x-axis is from a to b. So we're going to take this this horizontal line or horizontal line segment. We're going to revolve it at 360 degrees with respect to or around the x-axis. So that will create this right cylinder that basically is kind of laying down here. Okay. So it creates this right cylinder. When you look at this cylinder as it's laying down, the height of the cylinder is basically at a distance from A to B, which is B minus A. Okay. The radius is y equals c. And we also look at, so what is the circumference? So this is the circumference. So what is the length of the circumference? The circumference in general, it's always 2 pi times the radius. So the circumference is going to be 2 pi times c. Now if I have a knife, okay, I scissor, I kind of slice horizontally the cylinder right here, and I open it. So I'm going to have something like this, where this B minus A is the height of the cylinder, and this distance here is going to be the circumference, which is 2 pi times c. Okay. And so for us to find to find the surface, the area of the surface of this cylinder is the same thing as finding the area of this rectangle, where one side is b minus a, the other side is 2 pi times c. We know the area of a rectangle is base times height, or width times length. So you're going to have a b minus a, quantity b minus a times 2 pi times c. you can rearrange as 2 pi c times quantity b minus a, which give us the surface area of this right cylinder. So we're going to use the same concept when we're dealing with a different curve that are not like a horizontal line, this curve we give here. So when you revolve this with respect to the x-axis, you're going to create this this circle, and so then therefore you're going to find the area, you're going to find the circumference of the circle, because the radius is basically the function itself, f of x. So that means the circumference of this circle is going to be 2 pi times y. Y is f of x. And this side, we know it's the length. So that will give us the arc length, which we know it's L. We call it L. So the surface area in this case is going to be, in general, is we're going to end up getting 2 pi times the absolute value of y, which is the radius, and then times dl. dl is the arc length. So we call this a ds. ds is the surface element. Okay. But the dl, we know it's the length of an arc. So we know dl, which is the arc length element, is a square root of 1 plus f prime of x squared dx. That's dl. We stated that earlier. So here we then going to replace dl by square root of 1 plus f prime of x squared dx. So then we end up with 2 pi times the absolute value of y. The reason we're putting absolute value of y because y is the radius. So if y is in the negative part, then we need to put absolute value. So it's a positive radius. So then for us to get the area of the surface, we call that S, or the surface area, area of the surface area of rotation, we will integrate from a to b, because a to b, a comma b, that's at the interval. We're going to integrate this whole thing. It's going to be the integral from a to b of 2 pi times the absolute value of y, and then times square root of 1 plus f of x squared dx. So that becomes then the area of the surface. We can call that S, or we can call that SA, or S stands for surface area. So this is the area of the surface generated by the curve y equals f of x on the interval AB about the x-axis. So that gives us the formula that we're looking for. Now what you should notice here is when you do the rotation with respect to the x-axis, the radius is y. So you're going to have a 2 pi times y. Rotation about the x-axis, you get a 2 pi times y. If it's a rotation about the y-axis, you're going to have a 2 pi times x. So that's what you have to make sure you understand. So let's take an example. Find the area of the surface obtained by rotating the curve y equals x cubed, where x is between 0 and 3, about the x-axis. So about the x-axis, we can just write down directly the formula. S equals the integral from a to b of 2 pi y times square root of y plus y prime squared dx. So we have to write this down because it says about the x-axis. Now y is x cubed. Okay, so x cubed will go here for y, and then x cubed will go here. It's going to take x cubed prime and then square it. As you can see, when you graph y equals x cubed, is this, we need only this positive part from 0 to 3, because it says so. And the radius therefore is y, the radius of the circle. So we need the derivative y prime So we differentiate x cubed to get 3x squared, and then we square it because it says so. We get 9 times x to the fourth. We add 1 to it, and then we put this under the square root. So it should give us this. Now here we have y cubed. So when we go plug in, we have the surface area equals the integral from 0 to 3. So those are the interval a and a and b. 2 pi y, and then the square root of 1 plus 9x to the fourth dx. But you cannot have this two variables on the same integral. So we will need to, because this integral is respect to x variable. So we cannot see y. So that's why we're going to replace y by x cubed, because y is x cubed. So then when you look at this integral, everything is in terms of x, which is good. So to integrate, we see that here we have x to the fourth. So whatever is under the square root must be u. So when we take the derivative of u, we're going to bring x cubed dx. Right? So u is 1 plus 9 times x to the fourth. Du is therefore 9 times 4 times x cubed dx. So we want to find x cubed dx from here, so we can divide both sides by 36. 36 comes from 9 times 4. And because I want to change the x integral to the u integral, so I will go and also change the limits of integration. So I said when x is 0 into here, I get u is 1. When x is 3, plug in 3 for x, I will get u equals 730. So when I change my integral from x integral to u integral, I'll get 1. I'm going to integrate from 1 to 730 over 2 pi times, now this is a square root of u, and then x cubed dx, we know it's a du over 34. So now I have the u integral. I can bring all the constants outside, 2 pi over 36. Then I will integrate u to 1/2, which give you u to 3/2 over 3/2, divided by a fraction, makes 3/2 to be 2/3. Simplify 2, so get pi over 9 times 3, which is 27. Plug in 730 for u, minus, and then you plug in 1 for u, and then you get the answer. And so we're going to stop here. This is case 1. We'll discuss case 2 on next slide, next video. Thank you.